Okay, I'm looking at problem number 2 from the assessment review, and I said that I would come back to it and we'd look at why is this the way it is, and why do I have a hole and not a vertical asymptote is kind of the big question in this. So the function is sine of x plus 1 over x squared. Okay, so let me get that down here. That is sine of x plus 1 over x squared. Okay, so looking back at the question, we've got a couple of options here. We have 2 about horizontal asymptotes, and we want to show that it has, whether it has a horizontal asymptote at 0 or 1, and then we want to look at 0 and see if there's a vertical asymptote there. Okay, so I think we were pretty clear about the horizontal asymptotes. If I take the limit as x approaches infinity of sine of x plus 1 over x squared, because sine is continuous, that's the same as the limit as x approaches infinity of x plus 1 over x squared, which gives me sine of 0, because this guy goes to 0, which is 0. So y equals 0 is definitely a horizontal asymptote. Let's try the limit as x goes to negative infinity of sine of x plus 1 over x squared, which would be the other possible asymptote. But again, because that's an x squared, this guy is also going to 0, which gives me the same horizontal asymptote. So both left and right, we're going to 0, y equals 0. Okay, so that was the indisputed part of the problem. So that makes 1 true, makes 2 false, right? The question now is about part 3. So let's revisit that. Part 3 of the problem asks if it has a vertical asymptote at 0. Okay, so how do I know that f of x is equal to sine of x plus 1 over x squared does not have a vertical asymptote at 0? Okay, it is clear that the limit as x approaches 0 of sine of x plus 1 over x squared is a little funky here, right? So this is going to give me sine of the limit as x approaches 0 of x plus 1 over x squared. Okay, so what can I do with this, right? Okay, so we have to do some examination of this function. It is clear that when x is 0, this has a non-removable discontinuity. Non-removable, non-removable, non-removable. So this thing has something going on here. Now, if I am coming from the left, I am getting close to 1 in the top, and I'm getting close to a positive number here. So whatever it's doing, it's going this way. Okay, so if I am coming from the right, this is also getting close to 1. That's getting a positive number. It's coming this way. So this means that this limit, the limit as x approaches 0 of x plus 1 over x squared is infinity. Now, I apologize for something that I did in class because I played a little bit of a game there and I got a bit of a wrong answer there. That is clearly infinity. If you don't believe me, I'm going to flip over to Desmos here for a second and show you what I'm talking about. Okay, so I'm entering into here y equals x plus 1 divide by x squared, and if you look, there's the function. Okay, so just as we predicted, we have that asymptote there at 0, and we have it going to infinity from both sides. So this means that I have the sine of infinity. Well, kind of. like if I think about the sine function as it goes out to infinity, this thing oscillates, right? Oscillation means that the limit itself does not exist. Okay, does not exist. So here's my dilemma, right? If I make the tube, I can never find a value for which all of the function is going to be inside the tube. It's always going to have humps on the outside if I make the tube too small. So even by the definition of a limit, that limit does not exist. So this is a DNE kind of situation here. Now, how do I know that that is not an asymptote? Okay, so let's think that through. Okay, so I have three possible situations. Either an asymptote exists because the function goes like this and like this. The function goes like this and then like this, or its opposite. Or the function goes like this and like this, right? So mind you, this second situation can also be something like this, right? So this one says the limit as x approaches 0 of f of x is infinity, right? So that's not our situation. This one says the limit as x approaches 0 of f of x is negative infinity. Also not my situation, because here the limit exists, here the limit exists. Here the limit as x approaches f of x approaches 0. Sorry, f of x as x approaches 0 does not exist. Aha! So this is still up in the air. But note, I would have to have the limit one way going to infinity, the limit going the other way to negative infinity. Now remember, my function is f of x is equal to sine of x plus 1 over x squared. So, I don't know what's going on here. Okay, but I do know something for sure. This function, no matter what it does, is always between -1 and 1, because the sine is always between them. Okay, so that means this function is trapped in here. And as I get close to 0, it's still trapped, which means that if I'm coming from 0 to the left, it goes and gets stuck. Or it might get stuck here. Sorry, that's coming from the right. If I'm coming from the left, it's going to go and get stuck. Or it's going to get stuck there. It's trapped because it's a sine function, and the sine is always trapped between 1 and -1. So, this cannot have an asymptote. Not going to happen. Always trapped between 1 and -1. So, no vertical asymptote. The only other possibility that I have is that that limit does not exist, and it's because the two sides are approaching two different limit values, and those limit values are somewhere between 1 and -1. Okay, so the limit as x approaches 0 of sine x plus 1 over x squared from the left does not equal the limit as the sine approaches x from 0 from the right of the same function. So it doesn't approach the same value, so the limit does not exist. The limit does not exist tells me that this has to be the case, but it also is the case that because it's the sign, I'm trapped between 1 and -1, which means it doesn't actually have to be a hole. It can be some sort of jump. Who knows? It doesn't matter, okay? And in fact, it's actually not determinate, and that's a bit of a trick to the whole problem. But the bounded nature of the sine function is what causes this to happen. Okay, so wrapping this up one last time, keep in mind that the sine function always has to be between 1 and -1. It's bouncing between them. I have a limit here as I go to 0. Because I can't exceed these, my limit has to be, if it exists, has to be non-infinite. If it's non-infinite, I have no asymptote. So this definitively rules out number 3. So, does it have to be a hole? No. So this is a rare case where you can actually have a function that is continuous everywhere but x equals 0, and it has no asymptote, and it's actually not necessarily a hole. And probably it is not, because that limit is indeterminate at 0, but we know that the limit does not exist. Alright, so it's a bit of a complex problem, but it's the one we got.